嗨，大家好，大家好，大家好，新早。Okay, so if you think that it is too hot or too cold, the control panel of the air conditioning is right there. Okay, so please do it yourself. Okay, you may do it at any time, even when I'm talking here. It's fine. It's fine. Just go there. And pick the temperature you feel better. Okay. 冷气那个要控制面板在那里啊，那个随时好不好哈？你就也不用管说，哎，那个张清月还在讲那个什么什么，不用管这个，你就直接站起来走过去调整你想要的温度就可以了。Okay, I think I forgot to say why I needed to add everyone into this group on Teams. Okay, the story is this. The course actually is the combination of two courses. One in the computer science department, the other the international program. Okay, so on the Teams, we have two groups. One is this one. You can see this one. It's the group for computer science department. Okay. The other group right here, IN 106, is the one for the international program. Now, unfortunately, I don't find a way to broadcast simultaneously in two groups. I don't know how to do that. Maybe it's impossible. Okay, so the thing is that I have to choose one group and always broadcast there. Okay, I choose this one, CS 107. So I need to add every member of the other group, IN 106, to the CS 107 group. That's it. And I think I might have done that. Perhaps. I have done that yet. But when I did that, maybe some people have not taken the course. I mean, some people may take the course after I move all the members. After I copy all the members of the IN 106 group into the current group. It's possible. Or maybe I just missed you when I copied the members. It's possible because it's not automatic. I added the members one by one into the CS 107 group. And it's maybe the case that I just missed someone. Okay. So if you cannot see the current broadcasting online, okay, if you cannot, then it might be the case that you are not in the group. So please tell me, and so that I can add you in. That's it. 所以就是跟大家报告，为什么会说哈，就是说你如果是那个英专班的那个离散的群组，然后你不能看到资工这边 CS 107的群组里面的影片的话，那请告诉我，因为是这样跟大家报告，我们这个课程其实实质上是两个课程，就是英专跟资工合并。那所以在 Teams 上就会有两个群组，你看左边那个 IN 106，那个就是那个什么，那就知音的群组哈。那右边这个 CS 107的资工的群组，但是因为我会就是广播嘛，好，就像现在这样子。那直播可是我 不知道，也可能根本没办法同时在2个群组去直播，所以我只能选一个群组。那我不就只好把 IN106的那个群组里的名单加到 CS107嘛，然后我在 CS107这边直播，是因为这样子。但是那个名单，因为它没有自动加的功能，我是手动一个一个贴进来的。那一个一个贴进来，我怕有漏啦。那以及就是说我怕我贴进来的以后，会不会我贴进来以后，你才把加签单或什么东西交出去，然后你才选这个课，那我就没有贴到你的，也有可能。所以就是如果您是不能看到 CS107群组里面的影片哦，烦请告知，那我再把你加进来。为什么是有人丢我聊天呢？该不会他现在就在说他没有被加进来？可是我不敢点，不是我不敢点，是因为他这算是我可以把他给我的讯息公开吗？不知道是谁，大家有看到吗？那边有个1。果然呢，他说他看不到，可是我觉得他可能去错群组了。Okay. So let us continue with the notations. This is a very common notation. Let me write it down in plain English.我不会吧？马上就被丢了，才回完。等一下。没有，他说他不在群组，可是我一加，他说已在，出现这讯息，我的经验就是早就加好了，所以应该没有问题。好 ，OK, so the first set, okay, you can see is in curly braces like this. Okay, so it's a set. It's the set of all n such that n is a non-negative integer. you read the vertical bar as such that. So what kind of values n do we have to consider? In fact, we have to consider everything, including the case where n is the refrigerator. Yes, that has to be considered. But it's not that we don't consider n to be the refrigerator. It's that the refrigerator is not a non-negative even integer. So the refrigerator is not in this set. Okay. So I mean, in this symbol, we consider the set of all kinds of n, whatever kind of values n, that do not have to be numbers, okay? Such that n is a non-negative even integer. So you consider the chair, for example. You replace n by the chair. Is the chair a non-negative even integer? No, it is not. So it's not in the set. But when you consider n to be, for example, 6, you ask, is 6 a non-negative even integer? 6 is non-negative. It's at least 0. It's even. Yeah, it's a multiple of 2. 6 is 2 times 3. It's also an integer, so 6 is in the set. So in this way, you can verify that the set contains values like 0, 2, 4, 6, blah, blah, blah. Okay. In the second kind of similar notation, we specifically say that n has to be in a certain set, like in the set uppercase n, okay, of natural numbers. So this reads, it's the set of, or n in the set of natural numbers such that n is a multiple of 2. Again, you read the vertical bar as such that. So this time, you cannot consider the case where n is the refrigerator, because the refrigerator is not in the set of natural numbers. Okay, so you could consider, in fact, only 0, 1, 2, 3, and so on, the natural numbers. For each value of n, you ask, is n a multiple of 2? If it is, you put it in the set, otherwise you don't. So for example, you could consider the case where n is an 8. Is 8 a multiple of 2? Yes, it is. So 8 is in the set. So it's then pretty easy to verify that the set contains precisely 0 to 4, blah, blah, blah. Well, okay, good. 所以哈，这个地方就是介绍一个符号。这个符号呢，大家注意一下，因为过去我发现呢，很多同学不知道这个符号，所以哈要知道一下，因为这是算是标准的符号。就是哈，上面这个它是一个集合。为什么是集合？凡是你只要看到左大括号、右大括号，看起来长得像这样，基本上。通常就是一个集合，除非你有其他特别的符号的用法，所以这就是集合。什么的集合呢 ？n 的集合，所有的可能的 n 的集合。这一数你可以念 such that， 或者使得怎么样，就是满足什么条件的 n。n 要是呢 non-negative even integer， 非负的，不是负的，叫做 non-negative， 就大于等于0，然后 even 就是偶数 ，integer 就是整数。大家那个冷气有开得起来吗？我不太确定，因为我昨天在另外一个课程，然后就看到我同学开冷气，然后搞了老半天还是很热，然后最后到第2节的时候，就有同学告诉我说，老师那个冷气需要冷气卡才能开，我就哈真的哦，那不能开哦，然后我就去搬救兵，然后救兵可能也有一点 delay 到。所以呢，直到我那个结束的时候，救兵都还没有来啊。所以如果大家有类似这种情况，快一点跟我反映，好不好？让我可以及早搬救兵。好 ，OK，so 不，对不起，我现在要念中文了，混乱。好，就是说哈，这第一个集合是所有可能的 n 的集合，但是这 n 要满足那一数后面的条件，就是它是非负的。non-negative 就大于等于0，非负的 ；even 就偶数的 integer 就是整数，要是大于等于0的偶数啦。那什么样的 n 会是大于等于0的偶数？就是024这些啊，02468这些。好，所以这集合是这样子。那这里哈，你说，那张金瑞，你这样没有去指定这个 n 要考虑哪些可能的 n？我可不可以考虑 n 是冰箱的情况？其实是不但是可以，是要考虑。就是说那个 n 哈，它没有特别写那个范围，其实就是说你 n 是什么都要考虑，你只是譬如冰箱好了哈 ，n 取冰箱，其实你也要考虑，不一定要是数字。只是冰箱你套到后面这个一数后面的条件，你发现冰箱不是大于等于0的偶数，所以冰箱才没有在这集合里，并不是因为不用考虑 n 是冰箱的情况，是要考虑，只是冰箱不符合后面的条件，好，是这样子。那我们现在来看哈，那个第二个集合呢，这是另外一种也是常见的写法，而且可以消除刚刚那个冰箱的疑虑哈，就是说你一样左大括号右大括号，所以这是一个集合。The set of 什么东西，所有可能的 n 值的集合，但是这里又规定了 n 要属于大 N， 这个大 N 就是自然数集，所以这时候就不用考虑那个小 n 是冰箱的情况，因为冰箱不自然数。一数一样是 such that， 使得呢这个 n 是 multiple of 2， 就是2的倍数，2的倍数，所以这个就是说。有哪些自然数是2的倍数？这样的意思。好，这个小 n 呢，你要考虑，因为它又是属于自然数及大 N， 所以就你要考虑的小 n 有0、1、2、3、4这些。那哪一些是符合后面的条件？是说小 n 是2的倍数。譬如说4就是小 n 是4的时候，好，那这个4是 multiple of 2， 就是2的倍数，所以4有在这集合里面。Okay, so this is a very common notation. For representing sets. Is that good? Okay. OK， 这样可以吗？不好意思哦，因为有同学一直在丢我说他看不到，所以我就一直回。可是对啊，我也不知道。其实我有遇过这个问题啦，就是以前也有别的会议，然后我就是那个我就是里面的成员，可是 Teams 怎么样就不把那个正在进行的会议丢出来给我看，我也不知道为什么。那我不知道，刚可能同学有遇到一样的情况，那我有点无能为力，这样我不知道怎么办。好 ，OK， so next we are gonna talk about functions. A function is a mapping. In fact, yeah, a function is understood as a mapping. I guess most of you may have been familiar with notations like this one. F of 1 is a 4. But in fact, we understand this as saying that the function f maps 1 to 4. It maps something to something. When it maps x to y, we say that f of x is a y. Okay. So in fact, a function has a domain and a codomain. The domain is the set of things that are gonna map to others. For example, the common notation is this one. Okay, this set, this blue set containing 1, 2, and 3 is called the domain of the function. It means that the function has to map members of the domain into other things. Okay, it has to map each of 1, 2, and 3 to something. It has to map each element of the domain into something. Okay, so that's it. It's like this. When you say that f1 is a 4, f of 2 is a 5, and f of 3 is a 4, it means that 1 is mapped to 4, 2 mapped to 5, and 3 mapped to 4. So you can see that everything in the domain, including 1, 2, and 3, are mapped to something. The other thing about a function is the codomain. The codomain is again a set. It's in fact this blue set. This green set. Okay, what does the codomain mean? Okay, the codomain needs to contain all the things that something can map to. For example, f maps 1 to 4 here. It maps 2 to 5, and it maps 3 to 4. So the things that get mapped to include 4, 5, and 4. Now, the codomain needs to contain all those, but it may contain other elements. It is fine. The thing is, a function is there to map every element in the domain to an element of the codomain. So in this case, the blue set is the domain containing 1, 2, and 3. So the function f has to map each of 1, 2, and 3 to something. So we need to have f of 1 being something, f of 2 being something, f of 3 being something. Now, what does something mean? Okay, something means an element of the codomain. In our case, the green set containing 3, 4, and 5 is called the codomain of the function. So in this case, everything has to be mapped to an element of the codomain. So the value of f of 1 should be 1 of 3, 4, and 5, one of the elements of the codomain. The value of f of 2 has to be 1 of 3, 4, and 5. Again, one of the elements of the codomain. The value of f of 3 has to be 1 of 3, 4, and 5. Again, one of the elements of the codomain. So it means that every element in the domain should be mapped to an element of the codomain. That's it. So, is that good? I guess most of you are more familiar with the yellow notations. F of 1 equals 4, F of 2 equals 5 or something, yeah. But that actually means, for example, that the function f maps 1 to 4, 2 to 5, and 3 to 4. So each element of the domain, including 1, 2, and 3, gets mapped to something. Gets mapped to what? To an element of the codomain, to one of 3, 4, and 5, which are the elements of the green set, the codomain. Okay? So that's it. Is that good? It's not something deep here, but we need to know this because this is basically the common notations. Yeah. 我们现在来介绍函数。函数呢，英文就是这个 function。那 function 呢，我猜测啦哈，各位比较熟悉的函数的。就是对各位的对函数的印象可能是像黄色这个部分这样 ，f1 等于4 ，f of 2等于5 ，f of 3等于4这样子。好，那但是我们其实哈，我们是把函数理解成一个什么呢？理解成一种对应 ，mapping。map 就是把它对过去 ，mapping 就是把它这个加 ing 变当做名词用 ，mapping。这个是 p， 我写的不清楚，对，这也是 p 哈。mapping， 这个一个 mapping 是长得什么样子呢？我这样讲哈，跟大家报告，黄色的部分我们是这样解释哈 ，f of 1等于4 ，f 括号1等于4是什么意思？叫做 f 把1对应到4。继续我们看黄色的部分 ，f 括号2等于5，叫做 f 把2对应到5，后面 f 3等于4，叫做 f 把3对应到4。这样子，那这个对应的时候，那我们就有2个问题。一个问题是说，什么东西要被对应到别人？就是 f 括号里写的那个东西有哪些可能？好，就是谁？譬如说 f 括号 x 等于 y， 叫做 x 对应到 y 嘛 ，f 把 x 对应到 y， 那谁要被对应到什么东西？就是 f 括号里的那种东西，什么东西要被对应到别人？好，在什么东西？那些东西的集合。有一个名字叫做 domain， 好像通常翻成定义域，对不对？域就是我的领域的域。好，那在这里哈，那个 domain 呢，我们看上面蓝色的那个标起来的部分，有一个集合含有1、2、3，这个就是这个函数的 domain。意思是说 ，f 括号什么东西的括号里面可以填谁？可以填1、2、3。就是可以填这个定义域 domain 里面的元素，这样叫做 f 把这个定义域里面的元素，就是包括1或2或3哈，对应到别人这样子。所以 f 括号里的那括号里可以写的就是有1、2、3。比如说，好，我们看黄色的 f1 等于4，对不对？叫做 f 把1对应到4。为什么1需要被对应到不管是到4还是到谁？为什么1需要被对应到别人？因为1在 domain 里面，在定义域里面。那我们后面哈，那我们再继续讲 ，f 把不管什么东西对应到别人，那些别人是谁？就是比如说 f(x) 等于 y 好了，那些有哪些可能的值 y？ 有哪些东西可能会被对应到？好，就是有人对应到它，比如说 x 对应到 y， 那 y 就被对应到。哪些值可能被对应到？那些值。我需要呢，要在一个特别的集合里面，那个集合叫做 codomain，codomain， 就是这个 codomain。中文是不是翻成值域呀？值是不是啊？好像是吧。那好，不管了，反正就 codomain 哈。那意思是什么？就是说你 f 括号什么东西 ，f 括号不管什么东西等于多少。那个出来等于多少的那个多少那个值，一定要在 codomain 这个集合里面。就是 f 可以把随便什么鸟蛋噼里啪啦值对应到谁，那些谁必须要在一个叫做 codomain 的集合里。 OK， 那我们现在这样举一个例子哈，这个我们看黄色的部分 ，F1 等于4，所以有人对应到4咯 ，F2 等于5，有人对应到5咯 ，F3 等于4，有人对应到4，所以有谁是有被对应到？就是4跟5跟4，好，就是有人对应到4，有人对应到5，有人对应到4。所以那你看4跟5是不是都在绿色那个集合？绿色那个集合就是 codomain 里面。是啊，因为 codomain 有3、4、5。那你说，可是这样没有用到3、4没有关系的，是没有关系。我们并没有那个要求说一定要用到。你只要说 F 括号什么东西出来的结果一定都在 codomain 这个集合里就好了。那至于说这 codomain 会不会它其实还含有别的元素，还多一个3是没有关系。OK， in this case, the function f maps 1 to 4, 2 to 5, and 3 to 4, as highlighted in yellow. Okay. And it's easy to verify that the things that get mapped to, namely 4, 5, and 4, are all in the codomain because the codomain contains 3, 4, and 5. Okay. Now you might say, no, but then 3 is not used in the codomain. Well, in fact, this is fine. The restriction is just that everything that gets mapped to, including 4, 5, and 4 in our case, should be in the codomain. But the codomain is allowed to contain other elements like 3 in our example. In fact, nothing maps to 3, but it is fine to let the codomain contain 3 as well. Okay. Now the common notation for a function is just this one. Just this one. You write the function name followed by a colon, followed by the domain, followed by the right arrow, then the codomain. This is just like the prototype of a C++ function. In C++, the prototype of a function says, what is the return type? What is the function name? What are the arguments? Okay, what are the arguments? Okay. Now, it means that the prototype of a C++ function tells you what the function is like. Now, it's basically very similar. The notation begins with the name of the function. In our case, it is a simple if. So it tells you what is the name of the function. Then followed by the colon, followed by the domain, the right arrow, and then the codomain. So from this notation, you will know what can be put in the parentheses when you write f parenthesis something. Okay, f of something. Okay, the things are just the elements of the domain. And what are the possible values of f of something? Okay, they are the elements of the codomain. 所以这个符号哈，它跟 C++ 里面那个函数的 prototype 其实是差不多意思。C++ 函数的 prototype 不是就是写那个 return type 出来嘛，然后函数的名字，然后参数列嘛。其实这很像，你不然那个 prototype 是干嘛？就是告诉你这个函数长怎样啊。其实这里这个符号也是一样，它就是告诉你这函数长怎样。因为你看一开始这个 f 对不对？就是告诉你这函数的名字叫什么。那如果你不叫 f 也可以，然后冒号后面 domain， 然后右箭头codomain，对不对？你看上面那个紫色或者对紫色那边圈起来的那个部分就长这样。这样子它就告诉你什么呢？它就告诉你 f 括号什么东西的括号里可以填什么。就是填 domain 里面的那些元素。那 f 括号什么东西会等于多少？那些多少就是 codomain 里面的元素，是可能的候选人这样子。And I need to stress that a function has to map everything in the domain to something. It cannot omit an element of the domain. For example, what about this? If I say, let me just define the function in this way, in the yellow way, mapping 2 to 5 and 3 to 4, then it's an incomplete definition of the function. Because the domain contains 1, 2, and 3. Every element of the domain has to be mapped to something. So f will need to map 1 to something in particular. So the yellow part alone does not say what does 1 map to, right? So it's not a complete definition of the function f. Yeah, I mean, a function needs to map every element in the domain to something. It cannot omit an element of the domain. 那我们现在跟大家报告一个事情，定义域里面就蓝色那个定义域里面的东西是不能没有的，就是说 f 括号什么东西，它一定要把定义域里面的每一个元素都有对到什么，不管对到谁都可以，不可以说哎呀这个譬如说我现在黄色的部分黄色的部分，我说黄色的部分是不是上面讲的那个 f 那个函数 f 的一种完整的描述？不是哦，不是，因为黄色的部分只告诉我们 f 把2对应到5， 3对应到4，它没有说1对应到谁，这样是不行，因为定义域就是蓝色那个集合里面有1，定义域里面每一个元素都一定要被对到什么东西，不管什么东西都好，但是就是一定要被对应到什么东西。所以那 f 括号里的那个括号里要填的是真的是定义域里面的1、2、3，每一个都有可能，每一个都要可以这样子，不可以只有 f2 跟 f3， 也在这里也要有 f1。Is that good? Okay. Okay, so this is the thing written in a general form. Say we have two sets S and T, then we can write the function in this format, the function name followed by the colon, followed by the domain, which is a set, followed by the right arrow, then the codomain, which is again a set. So it's there to map each element of the domain S to an element of the codomain T. So if you adopt this kind of a notation, f of something equals something, every element of the domain can be filled in to the parenthesis. Meaning that every element of the domain needs to be mapped to something. And the value of f of blah, 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 blah should be what? Should be an element of the codomain T. Okay. That's it. But the codomain T is allowed to have one or several elements such that nothing maps to these elements. It's allowed. Like for example, in our previous page, the green codomain contains a 3, whereas nothing in fact maps to 3. It's just like this. You can see that nothing maps to 3, but it's fine for the codomain to contain a 3. Okay. Then we introduce two terms. One is called one-to-one. It's an adjective. Okay, we said that the function f is 1-to-1 if for different values x and y in the domain, the values that they map to, f of x and f of y, are different. So being 1-to-1 means that different values should map to different values. Okay, we cannot have two different values x and y mapping to the same thing. Okay, another thing is a little bit weird. The term onto sounds like a preposition, right? But it's an adjective in mathematics. Okay, it's very weird, right? Onto, okay, is an adjective. We say that the function f is onto if every element in the codomain is such that something maps to it. That is, for each element y of the codomain, there exists an element of the domain mapping to y. Is that good? So a function is one-to-one when no different elements of the domain can map to the same thing. That is, for whatever distinct x and y in the domain, the thing that x maps to, which is f of x, and the thing that y maps to, which is f of y, must be different. This is when we say that the function is one-to-one. And a function is said to be onto when every element of the codomain is such that something maps to it. In other words, for each element y in the codomain, you can find out an x in the domain such that x maps to y, or that f of x equals y. Yeah. 所以这里介绍两个稍微复杂一点的形容词啦哈。首先我们先把这个函数的这个一般形态的写法把它写好，就是说你假设你有两个集合 S 跟 T 哈，我们的函数的长相基本上就是这样写。这个符号我知道大家可能也许在高中的时候，就过去我所知好像到高中的时候没有介绍这符号。那我们现在就学一下这符号，这很简单，这没有什么学问，它只是一个符号。好，那 F 冒号那个 S 在这里就是那个 domain， 就是那定义域，然后右箭头大 T 就是那个 codomain， 意思是说这个函数要把 S 就是定义域里面的每一个元素去对应到 codomain T 里面的一个元素，什么意思呢？哇，讲这样子一副复杂的样子，不啦，没有啦，就是 F 括号的。F 括号什么东西等于多少？哈，括号里呢，你要 domain S 里的每一个元素都可以填到括号里。这个 domain S 如果含有冰箱跟冷气，你就要有 F 括号冰箱跟 F 括号冷气这两个东西。好，这样子，括号里的东西是 domain 里的什么东西都可以放进来。那 F 括号什么东西等于几？来，等于几的这个几呢，就是要在大题里面。就是要在 codomain 里面，要属于 codomain 这个集合。那，但是我讲几我觉得有点误导。F 括号什么东西等于几？大家会觉得一定是数字，没有，其实没有规定。你只要 F 括号出来东西是在 codomain 这个集合里就好。如果 codomain 含有冰箱跟冷气的话，好，你就是 F 括号什么东西的结果不是等于冰箱，就是等于冷气，这样也可以。好，那我们现在来介绍两个形容词，一个叫做 one to one。One to one 的意思来，我们说这函数哈，怎样是算 one to one？ 条件就在这里 ，distinct 就是它是不同的、相异的，异就是异类的异、异形的异，这样子就是不同的了哈。如果呢，凡是你在 domain 里面 ，domain 就是这里的 S，domain 里面凡是你挑两个不同的元素，让它去对应到别人 ，F 这譬如说这 X 就对应到 F of X，Y 就对应到 F of Y， 对不对？那对应过去那两个元素一定也不相等。就是这里写的 f of x 不等于 f of y， 如果符合这个条件，就叫这个函数 one to one。所以什么叫 one to one？ 简单讲就是不同的元素不会被对应到同一个东西。domain 里不同的两个元素，就这里写的 x y 不会对应过去对应到一样的，变成对 x 对应过去到 f of x，y 对应过去到 f of y， 结果 f of x 跟 f of y 一样，不会这样。如果不会这样的话，这个函数就叫 one to one 的函数。所以这 one to one 是一个形容词，它在形容说不同的元素不会被对应到同一个元素。那第二点呢，这个就有一点离奇了啦哈，因为我们一般就英文的理解 onto 是一个介系词，可是在数学上 onto 是形容词而不是介系词。onto 是这样解释的哈，一个函数怎样算 onto， 就是 在 codomain 就是这里的大题里面哈的每一个元素都有人对应到它，这样叫这个函数 onto。你看下面艺术啊，这样你在讲什么？好，那我们看投影片写的哈，这函数怎样会被称为 onto 的函数呢？就是对 codomain 那个大题里面的随便一个元素 y 都有人对应到它。什么叫有人对应到它？来，上面有个片语，那个我们看投影片，那个片语叫 there exists， 对不对 ？there exists 就是存在。好，这 codomain 里面随便找一个元素 y， 都存在一个 domain 里面的元素 x， 使得 x 就对应到 y， 叫做 f of x 等于 y。也就是说 ，codomain 里面的随便谁都有人对应到它，那个人当然就是要在 domain 里面。codomain 里面随便一个元素都有 domain 里面一个元素去对应到它，这种函数叫做 onto 函数。所以呢，这 onto 啊。在数学上它是形容词哦，它不是介系词。那我们这样看一下是否 OK？Is that good? We have examples. Not this one. Okay. Cool. Let us look at item B. In this item, the function f has domain containing 1, 2, 3, and codomain containing 1, 2, 3, and 4. We define the function by saying that it maps 1 to 1, 2 to 2, and 3 to 1. Then is the function 1 to 1? No, it is not, because here you can see that we have two different values in the domain, namely 1 and 3, that get mapped to the same value. In this case, they both map to 1. So you have two distinct elements of the domain mapping to the same thing. In this case, we say that the function is not 1 to 1. So item B is correct. The function is not 1 to 1. Let us look at item C. In item C, we have a function g. The function name is in fact arbitrary. You can have any function name, okay? Just like you can have any function name in C++, okay? The function has a domain containing 1, 2, 3, and 4, and a codomain containing 1, 2, and 3. We define the function by saying that it maps 1 to 3, 2 to 2, 3 to 1, 4 to 1, blah, 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 okay? Then is the function onto? What does it mean to be onto? It means that every element of the codomain needs to be mapped to. Something needs to map to this 1, something needs to map to this 2, something needs to map to this 3. Is that satisfied? Yes. You can see that we do have something mapping to 1. In fact, we have two elements mapping to 1 simultaneously. We have something mapping to 2. We have something mapping to 3. So every element of the codomain is that something maps to it. In such a case, we say that the function is onto. So item C is correct as well. And time's up, so take a break. Thank you. Hi, you can see from this table that immediately after discrete mathematics, I have computer programming 2 in 6014, okay, in another classroom in the same building. So basically, I will have to go to the other classroom immediately after this class. So if you want to ask me questions, you could go to the other classroom as well. And this should happen on every Thursday. And sorry for your inconvenience because I just have 2 consecutive courses lectures, okay, that are in different classrooms. But this one, okay, 6104 is just downstairs there, first floor, yeah. Okay, so after class, I will immediately go there. And if you have questions, you could also go there. Okay, so that we can solve the problem in another classroom. Okay, sorry for your inconvenience. Okay. We have verified items B and C to be correct. You have comments or questions? And I just got informed that there is a kind of activity called 观课. I don't know how to translate that in English. That is an activity of the Ministry of Education. So basically, I cannot say no. I cannot say no. You cannot come here because it's the Ministry of Education. Okay. So I don't know when. Anyway, it means that someone will come to our class to watch the lectures. OK， 就是说我刚得到一个通知啦，有一种叫做观课的活动啦，观课那个教育部的啦，那个我不能说 no 啦，所以到时候反正我也不知道什么时候，反正会有人来看就对了，应该是这样子。好，那到时候再说，好，到时候再说。那个如果有观课的时候，我再通知大家，拜托大家那个多多出席，好，多多出席。好 ，OK，so，我们来看一下哈，这个 B 跟 C 选项在搞什么鸟毛？这个 F 啊，它的 B 这选项啊，他说这个 B 这个 F 呢是一个函数，它的定义域是含有1、2、3。codomain 是后面这个，然后它这函数的定义是它把1对应到2对应到2， 3也对应到1。他说这函数不是 one to one， 刚丢，这样对吗？那我们就说哈，跟大家报告，你看哦，今天2个不同的元素1跟3同时都被对应到同个元素，都对应到1，2个不同的元素会对应到同个元素，这种会有这种情况发生的就叫做不是 one to one， 所以这个选项 B 是对的。它必须要任2个不同的元素对应过去都不会相同，只要你 F 括号里的东西取2个不同的对应出来，它就是假设 x 跟 y 不相等的时候 ，f(x) 就不等于 f(y) 这样子。好，不相同的东西对应过去永远都不相同，才叫 one to one。今天这个1跟3呢都对应到1，所以它这函数确实不是 one to one。那我们来看7这个选项，他说我有一个函数叫做 G。G 呢，它的定义域是这个，然后 codomain 是后面这个哈。那它把1对应到3， 2对应到2， 3对应到1， 4对应到1。他说这个 G 是 onto 函数，对不对？那我就跟大家报告怎样叫 onto 函数。onto 函数就是说哈，你这个 codomain 里的每一个元素都有被人家对应到。codomain 不是含有1、2、3吗？那就要有人对应到1，有人对应到2，有人对应到3。好，所以那是不是有人对应到1？有啊，你看后面3跟4都对应到1，有人对应到1。这里 G2 等于2，有人对应到2 ；G1 等于3，有人对应到3。所以这函数 onto 也没有错，所以这选项 C 是对的。好，这样可以吗？Next, we are gonna introduce union and the intersection of sets. So it's very simple. Union and intersection. The union of two sets is this one. It produces a set containing whatever is in the first set, whatever is in the second set, and of course, whatever in both sets. So for example, how about the element 3? 3 is in both sets, so it's in the union. What about 4? 4 is in one of the sets, so it's in the union as well. What about 2? 2 is in one of the sets, so it's in the union as well. So the union of two sets is the set containing every element that is either an element of the first set, an element of the second set, or an element of both. Okay, so that's it. Second, we introduce set intersections, written in this way. Okay, the intersection of two sets is the set containing anything that is an element of both sets. Anything that is an element of both of the sets. So it's very simple. It's like this. What about 2? 2 is an element of just one of the sets, so it's not in the intersection. Similarly, what about 6? 6 is an element of one of the sets only, so it's not in the intersection. What about 3? 3 is an element of both sets, so yes, it is in the intersection. Is that good? 所以我们就来介绍集合的连集。连集英文叫做 union， 那写法呢就是写这个样子。那连集就是什么？你两个集合的连集出来还是一个集合，这个集合就含有所有的第一个集合的元素跟第二个集合的元素，通通含有。好，通通含有。任何一个东西只要，譬如说哈，这个4它在第二个集合里，它就在连集里。这个2它在第一个集合里，那它也在连集里。那如果有一些元素是同时在两个集合里，譬如说3，那它也在连集里。那下面这个叫做交集，交集英文叫做 intersection， 交啦哈，安内交集，安内。这交集呢，就是呢两个集合的交集呢，也是就是出来是一个集合。这集合含有什么呢？所有同时是第一个集合的元素，也是第二个集合的元素的那些东西，就在交集里面。比如说，这个3呢，既在第一个集合里，也在第二个集合里，它就在交集里。可是这个2呢，2只在第一个集合里，没有在第二个集合里，它就不在交集里啦。好，就这样子，简单，好，简单这样子。我有没有过关呢？可以吗？所以好，继续往下。那这个，OK， we are gonna introduce the term quantifier. It may be the first time you hear the term. I don't know. There are two kinds of quantifiers in mathematics. One is for all or for each. The other is there exists, or you can say there is, there are, blah, 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 okay? There are shortest abbreviations for the two kinds of quantifiers. You can write for all in this way, using this weird symbol. You can write that there exists in this way. Okay, so the term quantifier sounds deep, but no, it's not. There are just two kinds of quantifiers, for all and there exists. That's it. And they appear in our everyday lives. For example, let me say that. In every month, there is a day when we have earthquake. In every month means for all, for each month of the year, right? It's for all. It's a kind of quantifier. In every month, there is a day when we have earthquake. There is a day means there exists. So you can feel that the quantifiers actually are used routinely, yeah, in our daily lives. Okay, next we introduce shorthand for the two words and or. You can write or in this way, and you can write and in this way. You might say, then is the symbol for or the same as the set union? Oh, no, it's not. You can see that. The set union symbol is like this. It's like you can feel that it's different from the symbol for or. The symbol for or is very sharp. Right here. And the symbol for and is also very sharp. It's actually not the same symbol as the set intersection. 那我们就来介绍一个词跟大家报告。这个词其实也是我们之后一些地方的主角，叫做 quantifier。quantifier 一听就，哎呦，张经略你好有学问哦！没有，这个完全就只是个名词而已，好吗 ？quantifier 有两种哈，一种叫做 for all， 就是对所有的；一种叫 there exists。there exists 就翻成存在，有一个啦，就有一个的意思。对所有的或有一个，对所有的呢，可以写成这样子的符号。有一个呢，可以写成下面这样的符号。那我要说的是 ，quantifier 其实它并不是说在数学上才有这东西，在我们日常生活中也一直都有这东西。譬如说，我刚刚举的例子，每个月都有一天有地震。来，每个月就是 for all 啦，每一个月嘛，每一个 for all 就是对每一个哈。每个月都有一天有地震，每个月里面呢都存在有一天那天地震 ，there exists 就是存在，所以这样你可以感觉得到，这个 for all 跟存在呢是我们平常在讲话就会讲到的。然后下面呢还有这个且和或，且可以写成这边写的样子，或可以写成这边写的样子。那你说？对吧？这个或不就是上面的连级吗？哎，我赶快哦，你看哦，上面连级这个符号哈，这不一样啊。连级这符号下面圆圆的啊，或这符号下面尖尖的啊，这个且是一样，好，它尖尖的，上面这个交集它圆圆的。OK，Is that good? Now we have sums and the products. When you want to sum up the values of k square over k being 1, 2, and 3, you can write the thing in this way. So you can see that it is simply 1 square plus 2 square plus 3 square. And if you calculate the value, it is a 14. You can write the things equivalently in this way. You are summing up all values of k square, where k belongs to the set containing 1, 2, and 3. So you are again summing up 1 square, 2 square, and 3 square for the result of 14, okay? The Greek uppercase letter pi means products. You are multiplying together values k square over k being 1, 2, and 3. So it is in fact 1 square times 2 square times 3 square, which is 36. And you can write the thing equivalently in this way. You are multiplying the values of k square over k being in the set containing 1, 2, and 3. So you are multiplying 1 square, 2 square, and 3 square together, and I have calculated the result for you. It is 36. Is that good? 好，那这里就有一些常见的符号啦，一个叫连加，就是一直加；一个叫连乘，就一直乘。那上面那个希腊字母大写 sigma， 那个就是连加。好，譬如说我们看第一行， 它那个就是我把所有 k 平方的值加起来，其中 k 是1到3，就是1、2、3，就是1平方加2平方加3平方。那第二行是一个相同的写法，我只是说我把所有 k 平方加起来，但是 k 呢要属于这个含有1、2、3的这个集合，其实也是一样，1平方加2平方加3平方。那更下面那个希腊字母大写派，对，那个念派。但是因为这是连乘，你就可以念它是 products 或什么都可以。好，希腊字母大写派，它这个意思哦，就是连乘，乘法的乘。那我把所有 k 平方的值乘起来，其中 k 是1到3，就是1平方乘以2平方乘以3平方。那我们再看最下面那一行，也是一样，把所有 k 平方的值乘起来，其中 k 要属于这个含有1、2、3的这个集合，那就是一样啊 ，k 可以取1，可以取2，可以取3，然后把它乘起来，所以1平方乘以2平方乘以3平方也是36。Ignore this for now. No, ignore that. Okay. We have seen items B and C. Let us look at item A. We have a set and we have vertical bars. So we are counting the number of elements of the set. In fact, yes, there are indeed the 3 elements. One is a 1. Another is a 3. The final one is itself a set. It's fine, but the set contains 3 elements. Although one of the elements is a set itself. So item A is true. Now for item D, we are considering the set of all values k between 1 and 5 such that k is a prime number. From 1 to 5, what are the prime numbers? They are 2, 3, and 5, right? Usually we do not consider 1 to be a prime number, so item D is correct. 那我们现在来看那个选项 A 哈，选项 A 呢，它就是说，因为我是一个集合，外面加那个两数嘛，就是集合的大小。那就是集合大小就是它有几个元素，那这是3个没有错，因为这集合含有3个元素，1、3跟另外一个元素，虽然有一个元素是一个集合，这集合含有7、8没有关系，就它这集合本身还是含有3个元素，它只是有一个元素是集合，这本来就没有关系的，所以选项 A 是对的。选项 D 哈，这个有左右大括号，所以这是一个集合哈。那这个集合含有所有的 k， 而且 k 要是在这个集合里面含有1到5的这个集合，就是 k 是可以1到5啊，1、2、3、4、5，5种可能。这一数就是 such that 使得怎么样，就是要满足什么条件 ？k 是 prime 就是指数的意思，或者你可以叫 prime number， 就是1到5里面有哪些指数啦？那就是2、3、5。那通常我们1不算指数，所以这个选项 D 也是对的。Is that good? Okay. Now we have set difference. I write a backslash here, but if you are more accustomed to the horizontal minus sign, it is fine. Okay, they are the same. They are the same. Yeah. So we are considering a set difference here. The result of the set difference is a set here containing whatever elements are in the first set, but not in the second set. You can see that 1 is in the first set, but not in the second. So it's in the set difference. This green element, let me show you. This green element is an element of the first set, but it's not an element of the second set. So it's in the set difference. Instead, what about 2? The element 2 is in both sets, so it's not in the set difference. So in this way, we can verify that item A is correct. What about item B? In item B, we want to sum up the values of I for I from 1 to 4. So it's basically 1 plus 2 plus 3 plus 4, which is a 10, yes. So item B is correct. Item C is wrong. Because the set on the right contains only 3 elements. What can be in the set? Only the elements of a set can be in a set. So in fact, for item C, on the left-hand side, we can only put 1 here, 2 here, or 3 here. Okay, we should say that 1 is an element of the set on the right. 2 is an element of the set on the right. But the set containing 1 and 2 is not an element of the set on the right. But item D is correct. In item D, we change to the subset relation. Now this time, item D is correct. Because in item D, you can verify that every element of the set on the left, 1 or 2, yeah, is also an element of the set on the right. So the subset relation holds. So item D is correct. Is that good? 好，那就跟大家报告哈。我们来看呢，这个选项 A 为什么对呢？选项 A 就是差集合的减法。那这里我是写反斜线，如果大家比较习惯写横的减号也可以。总之，这个差集出来就是一个集合，它含有什么呢？含有在第一个集合里，但不在第二个集合里的元素。譬如说，1就在第一个集合里，但不在第二个集合里，所以它在差集里面。这个很奇怪的，本身也是一个集合的这个元素，它是第一个集合里的元素，但不是第二个集合里的元素，所以它在差集里面。那么呢，如果你考虑这个2，你看哦，这个2呢，它是同时在2个集合里，所以它不在差集里面，所以这差集出来的结果看起来是对的，所以选项 A 是对的。那选项 B 是什么呢？选项 B 就是我把所有的 I 值呢加起来，其中 I 是1到4，就是简单讲1加2加3加4。如果你算一算，会发现对等于10，所以选项 B 是对的。选项 C 为什么错？选项 C 跟大家报告，这里呢我是用这个属于，什么东西叫属于？属于是说左边那个东西是右边那个集合里的一个元素。右边那个集合有什么元素啊？有1跟2跟3，所以那个属于的左边只能放3种东西，一个是1，一个是2，一个是3，其他什么都不能放。所以呢，左边放，譬如说放个集合含有1跟2，那没有啊。右边这个集合，请问右边这个集合有一个元素是等于这个东西吗？不是，好像没有啊。对啊，它是有1跟2跟3分别都是元素，但没有一个元素叫做含有1跟2的集合嘛。好，那选项 D 我就是修改选项 C， 把它改对。怎么给它改对呢？我把它改成子集合的关系，子集合这次就对了。为什么？子集合的意思是说，左边那个集合里的随便一个元素，譬如1或者2，也都是右边这个集合里的元素，这样叫子集合的关系。所以这个选项 D 是对的，这样我没有过关。终于啊，终于啊，哎呦呀，哦，你刚刚被关掉了。哇，我们前进到这个很酷的。Here we want to consider statements with quantifiers. In fact, we have statements with quantifiers every day in our everyday lives. For example, like I said, in every month there is a day when we have earthquake. In every month means for each month, right? There is a day means there exists a day. So we use both kinds of quantifiers in one sentence. So, I need to introduce a symbol. This one is the negation. Negation. Negation means not. Not. Okay. Here, if you look at this slide, you will say no. Hey, you didn't define what phi of x is. So the description here is incomplete. Yes, I admit that. But this is just a slide for presentation, okay? So here, phi of x means anything, any statement about x. For example, phi of x may be the sentence, x is a prime number. It may be the sentence that x is an odd number, okay? Okay. So we are gonna explore the relation between the two kinds of quantifiers. We're gonna say basically this. I think the example is better, is easier to understand. What is the negation of the sentence? It is sunny every day. Its negation is that there exists a day that is not sunny. So what does this tell us? This tells us that whenever we try to negate a sentence beginning with a quantifier, like every day in the sentence, every day basically means for all. For each day, it is a sunny day, right? If we want to negate a sentence beginning with the for all quantifier, in fact, we get a sentence that begins with the other kind of a quantifier. In this case, it's there exists. Okay. So you can see that the negation of the sentence, it is sunny every day, is that there exists a day that is sunny. From this example, we find that whenever we negate a sentence beginning with for all, blah, 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 we get a sentence beginning with there exists, blah, 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 blah. Right? So we can now look at this. Here we don't really care about what phi of x stands. It can mean anything, any statement about x. The sentence says that every x in the set of natural numbers satisfies the statement phi of x. Its negation, this is a negation, is that there exists a natural number x that doesn't satisfy phi of x, which is precisely this one. There exists a natural number x which does not satisfy phi x, which means that the negation of phi of x should be true. So the observation is that whenever we want to negate a sentence that begins with the for all quantifier, in fact, usually we call it the universal quantifier. We get a sentence beginning with the there exists quantifier. In fact, it's very often called the existential quantifier. Anyway, we are changing the type of quantifiers when we negate the sentence. In the second line, we are doing the same. Consider this sentence, which says that there exists a natural number x satisfying phi of x. What is its negation? If you say that it is not true that there exists an x satisfying something, it should mean that every possible x does not satisfy that thing, which is precisely what I write here. Every x in the set of natural numbers does not satisfy phi of x, so it satisfies the negation of phi of x. So in this example, you can again find out that if you negate a sentence beginning with one kind of a quantifier, you are just changing that quantifier to the other kind of quantifier. In fact, you also move the negation symbol to the right. You move this negation symbol to the right here. So the same rule applies to both cases. You can see that negating a sentence beginning with the for all gives you a sentence beginning with there exists. and you are moving the negation symbol to the inner part here. Similarly, negating a sentence beginning with this quantifier, there exists, okay, gives you the sentence that begins with for all, and you are moving the negation symbol inwards again, okay? So that's it. And I think maybe it could be good to introduce the names of the quantifiers. The for all quantifier is usually called the universal quantifier. Why do I have to write in this way? I can just type, right? The for all quantifier is called the universal quantifier. There exists quantifier is called the existential quantifier. Okay, so is this good? The first line says that somebody says that, okay, every natural number x satisfies phi of x. If that is wrong, it means that there exists a natural number x not satisfying phi of x, which is precisely this. There exists an x not satisfying phi x. In the second line, we imagine that someone says that, okay, there exists a natural number satisfying phi of x. Now, if that is wrong, so that we put the negation symbol there, it should mean that every natural number x does not satisfy phi of x, which is precisely this one. Every natural number x does not satisfy phi x, so it satisfies the negation of phi of x. So we have a general rule for negating a sentence beginning with a quantifier. You just change that quantifier to the other kind of a quantifier and let the negation symbol move rightwards. Is that good? 所以哈，就是来跟大家报告，这是这样子的。我觉得我还是介绍一个名词，没有什么学问的，还是稍微可能会比较好一点点。就是这个 for all 哈 ，for all 这是叫做在数学上叫一个 quantifier， 它有一个名字啦，叫做 universal quantifier， 存在一个 there exists。这个东西可以叫做，它有一个名字叫 existential quantifier，exist 就是存在的意思。好，那我们现在来看这个例子，我们要讲的是什么呢 ？negation 就是相反。我们要讲一句话的相反，一句有 quantifier 的话的相反会是什么样？来，我们现在这里有一个画面上有个句子，每天都出太阳，对不对？每天都出太阳。这句话有 quantifier 吗？有哦，每天都出太阳就是每一天嘛，就是刚刚的 for all 嘛，哈。每天都出太阳的相反是什么？有一天没出太阳。有一天来，什么叫有一天？有一天就是存在啊，那就是也是一个 quantifier 啊。所以你看哦，每天都出太阳的相反就是有一天没出太阳。每天本来是 for all， 变有一天是存在。所以我们就得到一个感觉，我们说，哎，原来你把一个拥有 quantifier 的句子取相反的时候，那个 quantifier 会变另外一种 ，for all 会变存在。所以我们现在来看这里，但我们要介绍一个符号，这下面挖沟这个，这什么东东？这个就是 negation， 就是相反的意思，就是 not 啦，就是 not。来，那如果你单看这个投影片，你会说张金略，你投影片在乱做。这个 phi of x 你又没有定义，拍谁？ 我心惊，我承认，但是没有关系，因为这只是一个投影片哦，它是为了 presentation， 所以不用那么那个。好，所以来我们来看哈 phi of x 在这里就会表示跟 x 有关的任何陈数都可以，比方说你要说 x 是质数 ，x 只有3个质因数还是什么好，随便任何跟 x 有关的陈数。来，我跟大家报告，今天有一个人说，这个是 for all 哈。对所有的自然数 x， 为什么我说自然数？因为这个 x 要属于大 A 嘛，当然是自然数集哈。对所有的自然数 x，phi x 都成立，叫做每个自然数 x 都满足 phi x， 你前面加个否定，叫做这句话是错的啊，那就是并不是每个自然数 x 都满足 phi x， 那什么意思？叫做有一个自然数 x 没有满足 phi x， 对不对？有一个就是这里。有一个，这就是存在。有一个自然数 x 没有满足 phi x， 就是它满足 phi x 的否定。我把那个否定的符号放在这里，对不对？所以这个你观察到一个什么事情，就是说哈，一句话如果是 for all 开头，你把它取相反的时候，它会变存在开头。那我们现在来看第二行，第二行也是类似。我现在说，我假想一个人讲了黄色这句话。他说存在一个自然数 x， 使得 phi x 成立。好，存在一个自然数 x 让 phi x 成立。然后我前面又加一个 not， 我说这句话是错的，那是什么意思？你看哦，有一个自然数 x， 存在一个自然数 x 让 phi x 成立的否定，不就是每一个自然数 x 都让 phi x 不成立吗？对不对？每一个自然数 x 都让 phi x 不成立，那就是右边这句话。每一个就是 for all， 对不对？好，每一个自然数 x 都让 phi x 不成立 ，phi x 不成立就是 phi x 的否定成立嘛，就是 not phi x。所以在这里你又再度感觉到同一件事，当你一句话呢，它是存在开头，你取这个否定的时候，存在会变 for all。所以我们现在得到一个一般性的原则是什么呢？一句话呢，如果是有 quantifier 开头，例如说 for all， 那你把它取否定，就是 for all 变存在，然后这个否定的符号，这个 not 就往右移动，就往内部移动，移到这里来。下面那一行也是一样的规则，你一句话如果是有 quantifier 开头，例如说是存在，你把这句话取否定的时候，就是变成另外一种 quantifier， 存在变 for all。然后这个 not 呢，这个否定就往右移，移到里面来。我们发现，竟然有这种规律。这样我有没有过关 ？Is that good? We're just saying that whenever you negate a sentence that goes like a for all blah 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 something holds, then you get there exists blah 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 that something does not hold. So you change the universal quantifier to the existential quantifier. And also, whenever you have a sentence that goes like, there exists an X such that blah, 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 and you want to negate the sentence, then the result is that every X doesn't satisfy blah, blah, blah. So you change the existential quantifier to the universal quantifier for all blah, 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 right? Now, what is the magic is that we are gonna apply this rule on and on and on to sentences with many levels of quantifiers. The first question is it possible? Is it possible that I have a sentence with 2 levels of quantifiers? Yes, it's possible. For example, if I say that, in every month, there's a day when we have earthquake. This is already a sentence with 2 levels of quantifiers. In every month means for all. There exists a day when we have an earthquake. There exists is the existential quantifier. So we have a sentence with 2 levels of quantifiers. Now we are gonna apply the rule that we just observed on and on and on to such a sentence. So it goes like this. We have a sentence that says, for all natural numbers x, there exists a natural number y satisfying something, which I call psi of x and y, and we don't care about what that is. And in fact, yeah, in mathematical writing, I should not directly do this, because if I write this, people will say that, hey, you have not defined what the psi of xy is. Okay, I admit that, but the slide is merely for presentation. So let me ignore that issue, okay? Psi of xy just means anything here, okay? Now, what are the three horizontal lines doing there? The three horizontal lines read is equivalent to. But in fact, there are other usages of the same symbol with different meanings. But here, okay, the three horizontal lines in this page will mean is equivalent to. So I want to say that the first statement is equivalent to the second. What I do here is this. You regard the first statement as for all x, something holds, yeah. I regard the thing enclosed in purple as one whole thing, just a whole thing. We don't decompose it and look inside, no. I just think that it is one thing. So the statement goes like this. It reads, for, it's this one. And yellow, okay, it reads, for all x, something enclosed in purple holds. What is the negation of this? From what we observed, when we want to negate a sentence beginning with the universal quantifier, like in this case, we're just changing the universal quantifier for all, okay, into there exists, into the existential quantifier. And then we move the negation symbol rightwards. So the negation symbol is now right here, just preceding the purple thing. Okay, so the first line is equivalent to the second line, simply because we have observed the rule that whenever we want to negate a sentence beginning with a universal quantifier, we just change to the existential quantifier and move the negation symbol rightwards. In our case, we move it to before the purple thing, the thing enclosed in purple. Now it's time that we look inside the purple thing. We look inside it. We find that, hey, it's not actually a whole thing. It actually consists of, well, an existential quantifier and then something. So it's like this. Existential quantifier. They exist, and why? Such that something holds. We want to negate such a thing. How do we negate such a thing? The blue part says that we want to negate it. When you want to negate it, you are negating a sentence beginning with the existential quantifier. And what you get is very simple. You just change the existential quantifier to the universal quantifier, just like in the third line. You change the existential quantifier to the universal quantifier. And again, you move the negation symbol rightwards. In our case, to before psi of x and y. So from this, you can observe a general rule for negating a sentence with multiple levels of quantifiers. The rule is very simple. You don't actually have to go through this process. You just say that, I have a sentence here. I want to negate it. I just change every quantifier to the other kind of a quantifier. and do nothing else. Yeah, of course, I also move the negation symbol rightwards. So it's like this. You can find that the result is that we change the universal quantifier to the existential quantifier to the universal quantifier, and you move the negation symbol to the innermost place. That's it. This rule applies to sentences with 3, 4, 5, or even more levels of quantifiers as well. Is that good?那我们就是跟大家报告。我现在来，我们前面这里会觉得这没啥回啊，这个就是没有啊，我就是一句话反过来怎么讲嘛，每天都出太阳的相反就是有一天没出太阳，每天变有一天，所以是 for all 变存在。可是我们要做的事是什么？我说一句话可以有多层的 quantifiers， 一句话本身就可以有多层 quantifiers。这种话如果要取相反，要怎么取？那你会先说屁啦，一句话哪会有多层 quantifiers？ 你是不是在唬我？没有哦，来，我跟大家报告，我这样讲，我觉得不要一直讲地震，好像不太吉祥。有一间台湾有一间大学啦有一间大学，每间教室都有装投影机。好吧，有一间大学每间教室都装投影机，有一间是什么？有一间就是存在啊。那一间大学怎么样？每间教室都装投影机，每间就是 for all 啊。所以一句话可以有2层的 quantify 啊。有一间大学的每间教室都有装投影机，单枪那就是存在在 for all 嘛。所以一句话确实可以长这个样子，它一句话可以长成像这种样子。多层 quantifiers， 那这种多层 quantifier 的一句话，你要怎么取相反？前面这个 not 怎么取相反？我跟大家报告，你就怎么样呢？你先把紫色这个框框里视为一个整体，你不要仔细去拆开紫色这东西，哎呦好复杂 ，no， 你把紫色这个当做一整个整体。那第一句话是什么？第一句话就是你看对每个 x， 紫色那个东西都对。的相反，前面绿色取相反。根据我们之前观察到的规则，它的相反就是我把这个 for all 有没有变成存在，然后把这个 not 这个绿色的否定往后移到哪里？移到紫色这一块前面，移到紫色这一块。紫色这一块我是从商行照抄下来的。那你会说张金略你在乱写什么？这3条线是什么？连上3条线不是啦，3条线就是等价于的意思。等价就是说2句话是一模一样的话哈。那我现在我做到了到这个地方的时候，我再来检查一下。我说现在我这个 not 已经移到这里，我这一次我把紫色这个东西拆开来看，我刚把它视为一个整体，我现在把它拆开来看。我说紫色这东西案情不单纯啊，紫色这东西是什么？它是存在一个 y 时的怎么样？它是有 quantifier 的。刚刚紫色这东西你仔细分解，它是存在一个 y 使得某件事成立。那这种话怎么取 not？ 存在一个 y 使得某件事成立，根据我们刚刚观察到的规则，你就是把存在变 for all 嘛，然后这个 not 再移进去，这个否定再移进去，移到这个 psi xy 前面。好，所以现在任何一句话，它有多层次的 quantifiers， 你都可以用这个方法呢来处理。时间超过了 ，sorry，I didn't notice that time is up，sorry，my bad。